Hey there, everybody. This video is going to show you how you can identify when a function is a quadratic function or not. When we're looking at functions, in order to identify if something is a quadratic function, it needs to be something that can be written in the following form. Y equals ax squared plus bx plus c, where a, b, and c are elements of the real numbers, and a cannot be equal to 0. So this notation here is an element of the real numbers is essentially just saying that a, b, and c have to be real numbers. Otherwise, it will not be considered a quadratic function. What I want us to notice here is a few things. When I'm looking at my variables, the variables is just x, so I only have one input. The largest exponent that I have on any given variable is 2. What you may refer to, or I guess hear about quadratics, is that they are degree 2 functions. That is coming from the fact that the highest exponent on any variable is a 2. That's what we should also be looking for. So let's take a look at a few examples. For this first one, y equals 3x plus 16 minus 2x squared. The highest exponent on any given variable is 2. A is not equal to 0, and all of these numbers are real numbers, so this would be a quadratic. This one works. When I'm looking at the next one, y equals 3x plus 1. Well, I don't have an x squared term at all. There is nothing that is being x squared. If that doesn't exist, then that means that a was equal to 0. So therefore, this is not a quadratic function. When I look at the next one, y equals 3x cubed minus 10x squared plus 5, I do notice that I have this squared term, which is great because that's what I need. However, I also have this x to the power of 3. We can't have anything that has a higher exponent than 2, otherwise that's going to be increasing the degree of the function and it won't be quadratic. So this would actually be a cubic function, and the reason it's cubic is because I have a degree 3, or an exponent of 3. If something is cubic, it cannot be quadratic. When we look at the next one, y equals x to the power of negative 2 plus 5x minus 3, what I want us to notice is this negative 2. Even though it is a 2, and that's kind of what we're looking for, it cannot be negative. So we have to have positive exponents, and it has to actually be positive exponents on everything. If you see a negative exponent anywhere, so for example, if this had even been like 5x to the power of negative 1, as soon as you see any negative exponent, it cannot be quadratic. All of the exponents have to be positive. When I look at y equals x times x minus 5, this is actually in what's called factored form. This is a different way of talking about quadratics, and it's the one that we have up here is what's called standard form. So if you notice how it's in factored form, you don't really have to expand it out, but if you don't see that, what's really important is that if you want to turn this into standard form, we can use the distribution property and multiply this through. So this becomes x times x giving us x squared, and x times negative 5 giving us negative 5x. This is now in standard form. We have x to the power of 2, we have an x squared term, and then here I have a b value of negative 5, so it's matching everything. A is not equal to 0. All of my parameters, a and b, are both real numbers, so then this would be a quadratic. I hope this helps you. Have a great day.